You're welcome. I'm ready to assist. What can I help you with today?
Today's video is going to be a very thorough and intricate tutorial on making a local offline chatbot using a Raspberry Pi. Now, beyond just actually going ahead and setting up the software, we're going to be making a system that has voice activity detection, text-to-speech with some pretty customizable voices, speech-to-text, and the ability to use any Ollama model that will actually run on whichever Pi we're using. Now, as a bonus, we're actually also going to go ahead and build Bob the Sentient washing machine, which was introduced.
Okay, let's build a local offline chatbot using a Raspberry Pi. We'll need to configure the Raspberry Pi to act as a voice assistant.
Okay,
and then create a system.
So basically, we're actually going to go a step further and build this washing machine device right here. I'm going to put all of the files up on GitHub so that anyone can design or play with and print their own. In addition to that, we'll go through every step necessary to actually get the display working, the speaker set up, and this will just be a very intricate and in-depth tutorial on something that I think a lot of folks would be interested in doing, which is a local offline relatively powerful and modern AI chatbot. So this video is going to make no assumptions about the viewer's level of technical expertise, meaning that if you have a decent grasp on the Raspberry Pi, it is very likely that you can probably skip the first quarter or third of this video, but I will have some in-depth timestamps to allow you to kind of jump around to where you need to be. So with that, let's go ahead and begin to build our chatbot and then our Bob the Sentient washing machine. There are going to be a few prerequisites to properly follow along with today's video, and I will just kind of showcase those right now. First and foremost, we are going to need a micro SD card with which we can install the operating system for the Raspberry Pi. If your computer does not have a micro SD card slot, it may also be helpful to have an adapter of a full-size SD card or some USB adapter. There are plentiful ways to actually get this linked to your computer. Beyond that, we are going to need a Raspberry Pi. For today's video, I am opting to use the Pi 5 as it is the newest and most powerful version of the Pi family. With that said, it is also possible to follow these steps on a Pi 4, and arguably partially would be a little easier because the Pi 4 does actually have an audio output jack as seen. Okay, that's a Pi 5, hold on. As seen right here on this Pi 4, and unfortunately the Pi 5 does not have an audio out jack, so we will need to basically just use our external speaker with Bluetooth if we're opting to use a Pi 5, which is quite doable. It just involves a little additional setup. So aside from the Pi and the micro SD card, we are also going to need a speaker of our choosing. If using a Pi 5, we will need a Bluetooth speaker, but if using a Pi 4, any speaker that plugs in with a 3.5mm audio jack should be good to be used. Following that, and kind of not strictly necessary, I am going to be putting an active cooler on the Pi as well, as it will just kind of keep temps smoother. And I do find that using Pis in 3D printed cases like this, assuming you're using generic PLA, can cause some level of warpage depending on how close the Pi is to any other plastic within the device. Finally, and this is again a little more important of a consideration for using a Pi 5, you're going to want the specific power supply necessary. In the case of the Pi 5, you'll want a 27-watt USB-C power adapter. This is a specific and somewhat odd specification power supply that is very specific to the Pi 5. If you're using a Pi 4, you can probably get away with using pretty much whatever you can find to power it. So with that, let's go ahead and just begin from step 1, which will actually be to open the box of the Pi and get our operating system set up and installed. I almost forgot to mention, we're also going to importantly need a USB microphone. If you're just going to be using this through the Pi and not putting it in a fun little bob, you can be rather flexible in terms of what type of USB mic you use. But if you are opting to build a bob, you will need to have like a very small button USB mic like this. I suppose we don't actually need to open this right now because the first step is actually just going to be getting the operating system for it onto our micro SD card. So for that, we're going to need a computer. I would assume that most viewers who are going to be watching this step will be using either a Mac or Windows computer, which either will work for this perfectly. So from that, we're basically just going to make sure that we open our SD card and insert it into our computer in a way that it can be read. So whether that be an external micro SD card reader or an inbuilt SD card slot for your computer, either will work prime. So in my case, because my computer that I'm using, a Windows laptop, does not have a micro SD card slot, it has a full-size SD card slot, I am just going to place this in said slot, which I will try to film without moving the camera angle, which is probably going to be a mistake because this laptop weighs far too much to lift with one hand. But with that said, I don't know how well you'll see this. The micro SD card is inserted into the computer, as denoted by the sound of the computer recognizing a device inserted to it. The first step we're going to do is go to raspberrypi.com/software, and from here we will be greeted with a screen to download the Raspberry Pi Imager program. This is a very simple to use program that really easily allows you to install your Raspberry Pi's operating system onto the micro SD card. I am using a Windows PC for this, but I have used this program on Mac as well, and aside from the download steps being slightly different, everything else will be identical in terms of actually using this program. So with that, let's just go ahead and click the download button for our specific machine, which in our case here is a Windows computer. And a pretty quick download, very likely depending on network speed, will resume, and then we click the downloaded file, and user access control will ask us, or user account control, to go ahead and install this, which we can just follow the prompt for. And you'll want to make sure to read the agreement through fully. And if you do accept it after having read through it all, you can just continue and go ahead to the next steps. And sure, I will create a desktop shortcut just because then it will be easier to find this program. All right, a very quick installation here, and if we click finish and check launch when we're done, we will see that we're met with the Raspberry Pi Imager software, as seen right here, now open on our actual machine. With that, and to not make this video look kind of confusing with like this open side by side, I will just now go ahead and close out of the browser, so we're left with our Raspberry Pi Imager. Now, I want to make note that for today's specific use case in the Raspberry Pi, we're going to be opting to use the Lite operating system, which is the Raspberry Pi operating system without any graphical user interface or desktop, meaning that when you actually interact with this Pi prior to using it as a chatbot, it will only be a command line terminal style operating system and not a traditional graphical desktop. While that may seem a little kind of intimidating at first, it is actually the better way to use this because having the desktop running on the system can introduce a lot of additional performance overhead that we are going to kind of need as we're going to be running offline LLMs, text-to-speech, and speech-to-text. So because of that, this is the correct way to go about doing it, and it will actually seem simpler once we get into it than it may seem in first glance. So with that, let's go ahead and now put that operating system onto our SD card. First off, we're going to select the Choose Device button right here, and this is something that is going to depend on the specific model of Raspberry Pi that you're opting to use to follow along with this video. As I am using an 8GB Pi 5, I will just be selecting the first option here, which of course is the newest offering as of the date of this video being filmed, the Pi 5. If you're using a 4B, you can just select 4 right here, and unfortunately the 0 would not be a suitable device for this video as it lacks the performance. So with that out of the way, we will just select our device, which in this case is the Pi 5, and move on to the next step, which is just choosing the operating system which we are going to be using. Now you will notice right here that we don't actually see the Raspberry Pi Lite operating system listed here, but there are a lot of other things here. So just to kind of make side note for anyone interested in the Raspberry Pi and what it can do, they do have emulator and game operating system, other specific purpose operating systems for home automation, 3D printing, and things like that. So there are a lot of cool options here and things you can do with these boards. With that though, we are going to be using the Raspberry Pi Lite OS, which we can find by just selecting this option right here for Raspberry Pi OS and then Other. Then we will be met with the first option, most likely, showing as Raspberry Pi OS Lite 64-bit, which we are going to go ahead and select, as this will be the no desktop environment operating system version. Once that is done, our next and not final step, but getting there, will be to choose storage, which of course we will just go ahead and see the newly inserted SD card that we have put into our computer to be used for this Pi. I will select that here, and then we will go next, but we're not going to immediately begin to flash the SD card yet. When we select the next button right here, we will be prompted as to whether or not we want to apply OS customization settings. These are actually really cool and useful for us to be able to do, especially when installing the Lite or no desktop operating system, because these settings will actually allow us to input the information for our Pi to connect to our Wi-Fi network and a few other things that just are easier to do here than actually from through the Pi once it's all set up. So we're going to select the edit settings button right here, and we will see that we get a few different panes of things we can actually tweak prior to even putting this SD card into the Pi. So we have a general tab right here, which is where we can set the host name for our Pi. We will be able to set a username and password, as well as configure the wireless network for our Pi. These are all things that I will actually go ahead and do right now. In addition to that, we can also set our locale settings, which is just kind of like the region in which you reside. We've now gone ahead and just configured everything right here that we want to, such as a username and password to access the Pi, the wireless information so that it will automatically be able to connect to our Wi-Fi when it boots up, and just some additional settings here relating to our locale. So just for the time zone and wireless settings, that is something that you can enter as well. Following that, I am going to go into the services tab right here, and this is something that you can or cannot do. It just kind of depends on how you want to go about actually accessing this Pi to set it up. So SSH is something where basically from the computer I'm using right now to actually flash this SD card, I will be able to use the terminal or PowerShell or anything like that, the command line apps, to actually go ahead and remotely access the Pi and enter commands on it, which can make things a lot simpler. However, there is a slightly higher barrier to entry to actually doing this and just getting everything set up. The alternative to this is to just plug in a screen, keyboard, and monitor to the Pi once we have the SD card inserted. I am going to opt to use SSH, as then I don't need a whole nother screen and keyboard and everything like that, but the choice is entirely up to the viewer and their level of comfort in kind of playing with some of these things. So with that, I am going to go ahead and enable SSH. Sure, I will use password authentication, which basically means we will see as I will actually just run through these steps real quick, and that is good. So everything right there is what I need. Finally, the final tab is the options tab right here, where these are just options for the actual Raspberry Pi Imager itself. I can disable telemetry, as I don't necessarily need that, and sure, we will play sound when finished. So now that all of our operating system customization steps have been completed, I will click save, and then we go back to this screen, which it feels like a while now, where we saw, would you like to apply these customization settings? And we have already set them all up, so we will click yes. This will now go ahead and basically just flash this SD card with the operating system, as well as the specific settings that we applied to it. Once the Pi Imager has completed, it will just show us this message right here, and we can click continue and then go ahead and unplug the card from our computer. The next step is just going to be to open up the Pi. I am fortunate enough to have a brand new inbox, one of these little guys right here. I do find that these just can be somewhat useful for my line of work, so I do keep a few of them around at all times. Now with that, and with the Pi unboxed, which is a rather drama-free affair, we're going to just go ahead and insert the micro SD card into the slot, which we did just flash with the Pi Imager. So I have to remove mine from this micro SD card adapter, as my computer needed this to fit in it. And then once that's done, it is really quite simple. Just make sure that the gold contacts of the micro SD card slot are facing up, and up here would mean like at the same direction as these pins that are going up. And then once we do that, we will just basically see that the card slides in just like this, and it will only slide in one way. So even if you were trying to kind of mistakenly put it in a different way, it just wouldn't properly fit. So you don't have to be super concerned about that. And with the slotted, with the SD card slotted, we are now going to go ahead, and if you have an active cooler, you can install it now, but if not, we can just proceed to actually plugging the Pi in and starting it up for the first time. Because the Pi 5 I'm using behaves best when it has its specific power supply that is branded for it, or at least the correct specifications for the power it draws, I am going to just go ahead and use this brick right here, which is a good thing to have, I guess. I don't really know what I was going to say with that. It's a power supply. So with the Pi plugged in for the first time, and assuming everything went well and it didn't get pulled off the table by the extremely short power supply cord, we are ready to go ahead and proceed to the next step. Now, please keep in mind that when we were enabling SSH or choosing not to, this will kind of determine the way in which you follow these subsequent steps, meaning if you don't want to deal with networking or kind of SSHing into this, you will just need to attach a keyboard, mouse, and a display to the Pi so that these steps can be followed from physically in front of it with a keyboard. If not, you will just be able to follow along with what I do here, where we will enter everything remotely through an SSH session from our PC in front of us. Now, as I am opting to connect to this using SSH, I am going to actually need to get the IP address that has been assigned to the Pi from my router. There are going to be a ton of different ways in which you will do that depending on the specific router, specific manufacturer of your router, and things like that. So if that is a little out of your scope of comfort, that is totally fine, but then I would just suggest kind of pretending that the steps here are being done directly in front of your own Pi with a monitor, keyboard, and mouse attached to it. Now, with that, if you do want to SSH, I basically just went to my router's admin page. I found the list of connected devices. I found the newly connected Raspberry Pi, which of course will have auto-connected since we set those parameters in the OS customization settings screen when we flash the SD card. And then I just noted its IP address so that I can now go ahead and SSH into it. So once you have the IP address of your Pi all set, if you're going to SSH in, you can just kind of do as I do right here. First and foremost, I should show that I am using Windows PowerShell to go ahead and do this, which you can find assuming you're on Windows as I am right here by typing PowerShell into the kind of system search, and then this will open up and you will be in the screen that you see right here. Next up, we're going to type SSH and then the username, which we set in the Raspberry Pi OS configuration settings, which for me was OMNS. Following that, we're going to type the @ symbol, followed by the IP address of the Pi, which we will have noted from our router's configuration software. And again, if you're just using this with a keyboard, mouse, and monitor attached, you can just kind of skip this step. And assuming everything has been entered correctly here in terms of the username and then the IP address of the Pi, we will get a message here basically saying, okay, like basically just kind of like a safety check here, and it's asking, do you want to continue connecting, which in this case I do. So I will just type yes, and then it will prompt us for the password for the Pi, which we would have entered in the OS customization settings in the Raspberry Pi Imager. So we will enter that password right here, and assuming everything has gone well, we will now actually see that our PowerShell prompt has changed from the one we saw when we first opened it, and we are now kind of remotely connected to this Pi and can therefore run commands as if we had this Pi directly hooked up to a keyboard, mouse, and monitor from in front of us, but through our actual desktop machine, which is kind of cool. Now, again, if you're using a Mac, the steps here are actually going to be completely identical, except instead of opening Windows PowerShell, you will just open the terminal application on Mac. Everything else following that will be completely the same, from just doing SSH and then hostname at IP, or at the username and then IP of the Pi. So it's kind of cool that it's cross-platform, very similar depending on whether you're on Windows or Mac, it doesn't matter. So with that, we can now move on to actually getting our Pi set up with the dependencies to make it an offline and local AI chatbot. Now that we're successfully connected to our Raspberry Pi, the next steps are basically just to set up the system to act as a functional and local chatbot. This is going to involve installing some packages, setting the system up so that our microphone and Bluetooth speaker, in the case of the Raspberry Pi 5, are able to be used, as well as actually downloading and installing a local LLM, text-to-speech program, and speech-to-text program with voice activity detection, so that when we are speaking, it is automatically detected and we don't need to really deal with any like button clicks for start and stop. It just makes it more natural and immersive. Being that this is the case, and this is going to be a relatively lengthy amount of just entering terminal commands, I do have the full list of instructions for this portion of the video up on my screen right here. However, as I will be going through these on video here in PowerShell, I am also going to make it a note to put these instructions on GitHub so that anyone interested in doing this can see them there and copy paste them from there if they would please. So with that, let's just go ahead and begin to actually get our Raspberry Pi configured to act as a local AI chatbot. The first things we're going to do are just to copy paste these first two commands right here, which you can kind of think of as just basically getting your system updated. So the operating system image that we have downloaded may not be the newest version based on when the Raspberry Pi Imager kind of updates the versions of the software. So this is basically like buying a new computer at the store, knowing it's been sitting on the shelf for a couple of months maybe. So when you get it, there will be updates for you to download and install when you first boot it. That can be kind of similar to what we are doing right here conceptually. This can take a little bit of time, so the best thing to do here is just sit back and leave it alone for a few minutes until it has time to properly update and install everything. Now during this, we may actually get prompted for a question here that probably looks like a lot of gibberish, and to me it does as well. So all we're going to do here is just type N and press enter, as basically it's not required what it's asking to do there for our simple chatbot purpose, so we can safely go ahead and skip that. Once everything has completed from running these first two commands, our next step is basically to just go ahead and install more things that will take an additional bit of time. And fortunately, we can actually install all of these things at the same time. So what these are right here, as I mistakenly cut instead of copy, these are dependencies that our script will rely on in order to actually be able to run as a chatbot. So to put it simply, you can kind of think of these as like connectors between what we're trying to do with the system and what the system needs to actually accurately understand what we're doing. That is obviously not a very scientific explanation, but as we paste in there and press enter, to put it a little more simply, basically some of the things right here are just like espeak-ng, which the text-to-speech we're going to be using actually relies upon to function. Beyond that, there are just some things here to allow us to use the Bluetooth of the Pi to connect to our speaker and things of that sort. So this is kind of where Linux is seen as a little more tech heavy than something like Windows or Mac, because Windows and Mac will kind of handle all of this under the hood for when you're using default applications. Again, I'm putting this kind of in a simplified manner. So in Linux, you sometimes need to get your hands dirty and just go ahead and do things as we have done right here. Now, fortunately, this did not take as long as I had anticipated, so with the conclusion of this, we can now just go ahead and move on to the next step, which again, keeping in with what we were just talking about Linux being a little more hands-on and under the hood, this is essentially giving our user permission to actually access and modify the audio settings of this Raspberry Pi. So we will run that right there. And upon the conclusion of that, we will actually need to either log out or log back in, or just restart the device. Now, being that I am on this through SSH, I am just going to reboot it by typing sudo reboot, which will go ahead and just restart the device. Now you will notice if you are doing this through SSH, it will close the connection that you had to the Pi because it is turning off and back on again, so the connection would not persist throughout that. So all we're going to do in this case of SSH being used for this is just wait probably 5 or 10 seconds, and then once we have waited that time, we can just go ahead and if you have previously entered commands here in PowerShell or even Terminal on Mac, you can use the up and down arrows to actually cycle through them, so you don't need to retype everything, specifically the command to connect via SSH, which I will now enter. And being that the Pi has had enough time to restart, we are able to log back into it, and we're basically back at where we were, except now our user account has permission to access and modify the audio settings. Being that these steps are now completed, our next step is going to be kind of an example of why Bijan is extremely frustrated about the removal of the 3.5mm audio jack on the Pi 5, because these are kind of a pain to get sorted with. So prepare yourselves. The next step is going to be enabling Bluetooth and making sure that our Bluetooth speaker is able to be connected. Again, this is a very Pi 5 specific thing, and if you have a Pi 4, you can just plug your speaker into the audio jack and not have to deal with these somewhat frustrating steps. So first and foremost, we are going to go ahead and just enable the system service for Bluetooth, which just think of as you're telling it you want to use Bluetooth, so turn it on, unscientifically put. Now, following that, the next thing we're going to do is kind of in a similar vein, just enable some more things for our user that will allow us to use the audio features and Bluetooth on the system. Now, if you do see this and say, wow, this is very verbose and kind of a pain, you're not alone. It is kind of audio on Linux is something that I personally find to be somewhat bulky. So basically, the steps here we're just going to sequentially follow by just copy pasting them. So this probably isn't fully necessary for the specific use case here, but it would just keep these services. So say you were using the Pi where you were just putting it in a different room, just plugging it in and needing it to still be functional. That would just allow these services to still run even if no one was logged into the Pi. Not necessarily in line with what we're doing, but I suppose better to have than not. So the next thing we're going to do here is just verify that these newly activated services are in fact running by pasting this, and we will get some output right here, which basically, assuming you don't get a blatant error there, you're probably all set to just move past this step right here. The next thing we are going to do, and that Q right here is definitely not supposed to be there. That is in the wrong portion, so I will remedy that for the actual setup guide. So the next thing we're going to do is another thing that does not need to be there, as I have already taken care of that and you have as well. Our next step is going to be to basically pair and connect to our Bluetooth speaker. Now, something that obviously in a desktop environment like this would be a few clicks of the mouse is a little more intricate when it comes to running a light version of the Raspberry Pi OS. So to begin, we're simply going to type Bluetooth CTL into the command line right here, and we will note that kind of the area in which we're typing in front of changes from our username on the Pi to a Bluetooth kind of in brackets, just to show that we're actually in the Bluetooth setup menu, to put it simply. There are a few different things we're going to run here before we get to actually connect to our speaker, so we will just sequentially start with the power on. And then next up, we are going to type agent on, and some of these may say like already done, already done. It's just better to do them and not have needed to do them than to not do them and needed to have done them. I hope that makes a little bit of sense. So the final thing we're going to type here is default-agent. And then finally, our next step, instead of typing scan on immediately, is actually to go ahead and take whichever speaker that we have decided to use for this, power it on, and then find whichever way your speaker has to actually enable the Bluetooth pairing mode, which in my case is just to press a little Bluetooth button there, which then makes a sound to denote that this speaker is discoverable. And once that has been done, we're going to type scan on, and this is basically just telling the device to look for different Bluetooth devices near it. Now we're going to, depending on how many networked devices you have near you, get a variety of different outputs here. So just look for the name of your speaker in these outputs, which in my case right here we can see is the Tribit X Sound Go. Now in PowerShell here, you can't right click and copy and things like that. So if you have your device selected and you are using a keyboard here, you can just type Control Shift and C, and that will actually paste that device. It will copy the device address there, call it, to put it simply. So following that, we have our information right here, and we're basically going to first type pair, and then we're going to need to paste it in here, which you can type Control Shift and V to paste in PowerShell or Terminal or something of that sort. And that will go ahead first and foremost, and then just say, is this a correct passkey, which obviously is not applicable here, so we just type yes. Following that, we're going to need to trust the device by just typing trust and then pasting in that address of the device that we had copied. And the final step here is to connect to it. So we type connect and then paste in the address of the device that we had copied, and we should hear a sound on the device to show that it's actually connected, which is awesome. And then finally, we can here type exit, and that will remove us or take us out of the Bluetooth menu and just back to kind of where we have been with the Pi in general. With our speaker connected to Bluetooth, our next step to actually get it working, and yes, there are more steps here. I will say this is probably the most frustrating portion of the entire setup guide. So think of this as like the hump, and once we get over this, it's hypothetically, knock on wood, smooth sailing. So our next step is basically to just type this command right here to get a bit of information about some of the audio devices connected to our system and things like that. So in this tree right here under audio, we're going to be looking for anything under syncs right here, where we will recognize the actual name of the speaker that we did just pair in the Bluetooth step, which in my case is this X Sound Go, but we want to make specific note of the number preceding it, which in this case is 69. You will see that it is also listed right here with a different number. We want to just make sure that we don't confuse the two. to, and we look for the one under syncs right here as denoted by this 69 number. Our next step following this is going to be to type wp-ctl set dash default, and then just the number of the device that we noted there, which in our case was number 69. So we will type that and enter it in, and it will look like nothing has happened, but that is actually normal behavior, and it's quite all right. The following step is to actually test for the first time our speaker, and basically we're just going to copy this, and it will play a very calm voice that is kind of a default Linux sound for testing speakers, where it's just going to say front, center. So if we paste that in right here, we should soon hear
front, center,
which is great, and that means that our Bluetooth speaker is now actually properly set up to be used for the voice output of our AI chatbot. And it is perhaps easy to kind of forget what we're even doing here with some of the intricacies of setting up these audio devices, but with that, we are getting closer. The next step is kind of similar to what we just did with the speaker, but fortunately a bit easier, and it involves just setting up our USB microphone. So prior to this step, you should have plugged in your USB microphone, and if you haven't, you can just go ahead and do it now. And following that, we're actually going to go back into the same menu. So you can use the arrow keys to just cycle up through previously entered commands if you would like, and we just want to type in this wp-ctl status command one more time. However, instead of looking here where we were previously, we are just going to reference this because truthfully I've forgotten. Okay, so we're going to be looking for our USB mic in the audio sources section. So if we scroll right here, we will see under sources there is one thing listed, and in this case number 66, which is our USB microphone. So with that, in kind of a similar manner, we are just going to go ahead and type the wp-ctl set default, and then this time with the number of our USB microphone, which in this case is 66. So we're going to just do that real quick, and then that should be all right. Now, looking at this real quick, I do believe that there is perhaps a mistake in these instructions here, because I don't actually believe this will work. Our next step, now that I have fixed some of these instructions right here, is to just go ahead and record a sample of us speaking or something to test to make sure our USB microphone is actually working. So we're just going to paste this command into the terminal, and once we have done this and pressed enter, we're going to want to make noise or something so that we will be able to actually see if the microphone is working. Beyond that, when you're done making your noise, you're going to type Control and C on the keyboard, which will kind of stop the recording from occurring, I guess could be said. So this is just a simple test, and now I will type Control and C to end this, and then we'll see that that has finished. And following that, all we're going to do, which to properly test our microphone and speaker system at this point, is just type this command in right here, and if everything has gone correctly, we should hear the recorded snippet through our speaker. This is just a simple test, and now I will type Control and C to end this. So that was very quiet, but again, that's just kind of, I'm far away from the mic, it's a small mic, and I don't think the speaker is all the way up. But now, pat yourself on the back and take a break, because we have successfully navigated the world of audio and Linux, and beyond that, we've done it without using a graphical user interface, so we went the kind of hardcore route. Our next step is basically to get everything ready for this to actually be an offline AI chatbot. Things like installing Ollama and just placing the script that will actually allow all of this to work into the new location that we're going to be making right now. So first and foremost, this step is just to make a new directory with a name for our project, which in this case will just be, as listed right there, voice chatbot. So typing or pasting this command in will basically just go ahead and make this new directory on our system. And being that has been made now, we can just go ahead and type cd, which will just change our current working directory into this new directory. So from right here, we just see this little tilde. If we paste this in and press enter, we're going to see that that has changed now to reflect the path in which we are now kind of working, to put it somewhat simply. So following this, our next step is to create a virtual environment to install all of our dependencies and things like that. This is just good practice, and actually in newer versions of Linux, you actually can't install certain packages and things like that without using a virtual environment, as it is good practice and can keep things from kind of overlapping or causing dependency frustrations. So we will just do this right here, which will go ahead and create this new virtual environment from within this voice chatbot folder or location in which we are in. And once that is complete, the following command right here is what basically will go ahead and activate our virtual environment. To get a visual feedback of this actually having occurred, you're going to notice that preceding this username at Raspberry Pi, it is now going to change when we press enter to just show that we are now in this little virtual environment. So that is kind of cool, and we're now in a safe virtual environment in which we can install dependencies carelessly. No, but kind of. So the next thing we're going to do is just upgrade pip. Just think of this as like updating the App Store on your computer. That's probably not a very one-to-one comparison, but it gets the job done, I suppose. And our next step is basically to go ahead and install a few dependencies that will allow our AI offline chatbot to function, namely Faster Whisper right here, which is actually an optimized version of OpenAI's Whisper speech to text, so transcription of our speech. Beyond that, it actually has the capability and is built in with Celero VAD, which is voice activity detection, which means that instead of having to manually start and stop this to tell it when we're speaking, it can go ahead and automatically detect our speech and begin recording when it does so. So that's why we're using the specific Faster Whisper version right here. Next, we have Ollama, followed by NumPy, which just think of as like helps it understand some of the like AI stuff that goes on here unscientifically, and then Kokoro, which of course is going to be our nice and rather good and lightweight text-to-speech library. So we'll just paste all of those in right here, and this may take a little bit of time, especially depending on your network connection speed, but it will go ahead and install all of these dependencies, which are really the foundational pillars of our offline AI chatbot. So once all of these Python packages have been hopefully successfully installed, the next step right here is something that I'm truthfully not 100% like certain how necessary this is, but just think of this as basically putting your car into sport mode so it will perform a little snappier and things like that. Basically what's going on right here is it's just allowing the speech transcription, so the Faster Whisper right here, to go ahead and utilize a specific number and more of the Raspberry Pi's processing capability or power, I suppose should be said. So first we just do this right here, and then following that we're going to type this source and bash rc, and that will actually, you'll notice right here, so our virtual environment became deactivated when we did that. That's almost like, imagine we have like a sticky note of notes that we want like our current working location to keep in mind. Unscientific. So that's basically like saving that sticky note, but for the changes to take effect, like it kind of has to reload. That's probably a really crap explanation. So to culminate that, basically we're just going to want to make sure that once we do that, we reactivate our virtual environment by just typing that once more, and we are now back in our virtual environment. So I will probably just add that to the instructions right here. So our next step now, and if you get like overwhelmed, you can just type clear and it will remove some of the previously generated text slop there. But our next step, now that we have all that done and are basically right here, is to actually go ahead and install Ollama. So this is probably something you're familiar with if you are actually watching this video. However, if not, Ollama just makes it very simple to actually download and run a lot of open source AI and LLM models. I want to just give a super brief crash course on Ollama, since that's how we're going to actually be using and serving these models. This is just ollama.com, and essentially think that what we just did would be akin to just clicking the download button right here, which would then download and set this up on our local computer, except we just did that to the Pi. Ollama, I guess simply put, could be thought of as like a catalog where if you search right here, or you just click on the search bar and then click view all, it will list out a bunch of different local open source with a grain of salt, AIs that can be run offline and locally if your device can handle them. So that is the big point that I want to bring up here, is that oftentimes with local AI and local LLMs, you will see folks building big, expensive, powerful systems to actually run these things because they are very, very performance and resource intensive. Now, running these on a simple Raspberry Pi is probably very opposite of how a lot of these models are run, but that is cool and it's totally fine to do. We just need to be mindful of the actual specific models that we choose to use. A lot of models right here are too big for this Raspberry Pi, and unfortunately that is just kind of the nature of these models, and their existence is very performance and resource intensive. So every model right here has its name and then a little bit of other pertinent information about it. So let's look right here at this Qwen 3 listing. We see that there are a bunch of different little numbers right here, and these actually refer to the specific available sizes of this model that exist on Ollama, or in general, but Ollama will kind of allow us to easily run them. For this Raspberry Pi, which is a Raspberry Pi 5 8 gig, I would basically kind of be a little nervous to run anything that was listed as 4B or above here. So basically you want to look for things like this 1.5B right here, Gemma 3 1B, or even the 270M, which is what we're going to be running right now, which would be a good model to be used on a Raspberry Pi 4B or something like that. Beyond that, you see Llama 3.1 listed as an 8B right here, which I probably would not be able to run on this Pi at all, even with the kind of concept of quantization. But this is actually a really good way to explain simply quantization and how it may allow us to run models that we otherwise would not be able to. So if we go back right here, let's say I want to run this Llama 3.1 8B model, which is listed at a size of around 4.9 gigabytes. Now, this is not a very reliable method in which to judge how much resource these models would take, but let's say for good measure that I had a 4 gig Raspberry Pi 5 and I wanted to run this model. If the size is bigger than the amount of RAM my Pi has, it's just not going to work. Again, it's not like one-to-one, like this isn't default how much RAM this thing will use, but for the purpose of what we're doing, we can kind of assume it is the case. However, if we see there is a view all button right here. So if we go and click on this, we see that this list of models right here, which only has 4 items, becomes vastly more expanded. So let's go back and find that Llama 3 8B model, which we can see, okay, it was 4.7 gigs. So that actually means that the one listed right there is this Q4. Now, these numbers following the models here are quantizations for the specific model. So basically, and again, this is not a scientific or factually accurate example, but it does serve the purpose of hopefully giving understanding. Let's say I have a storage unit that is 10 feet deep, and I want to put an item in there that unfortunately is 20 feet long. Well, if I were to quantize that item, it would basically allow me to have that same item, but shrink it down to a size that would actually fit in my storage unit. The downside of that would be that the overall quality of the item would be reduced proportionally to how aggressively we decided, or I decided, to quantize it. So this Llama 3.1 8B right here at this Q4 quantization is listed at 4.7 gigabytes. Now, unfortunately, let's say this is not going to fit on my Pi because it is just too big, or it won't fit in my storage unit, but I want this to fit in my storage unit. We can actually go down and look and see, well, okay, this is the 8B model as well, but for some reason it is now listed as 3.2 gigabytes right here with this Q2K prepended to it. So, prepended. Basically, this is a more aggressive quantization of that same model, meaning that the size is vastly reduced to the point where it could actually fit in my storage unit, but with the trade-off of this being kind of less detailed or a less quality item, but it would then actually fit. So there are tons of resources online and things like that to better understand quantization, but I did just want to quickly touch upon this topic right here, as I don't want to just kind of show like, oh, okay, we're going to use Ollama and download this one model and then like that's it. So hopefully this will at least have given a bit of insight into some of the different ways in which we can use like math and trickery to actually get these larger models to run on smaller, more resource constrained systems. Now, with our verbose explanation of Ollama out of the way, our next step is, fortunately, to just actually go ahead and use this command, which will install the 270 million parameter variant of Google's Gemma 3 family of language models. Now, this is a very tiny model, and we can see right here that at a size of 291 megabytes, it's extremely tiny for a large language model. However, it's really actually cool because a model this small that would actually be this lucid is not something that really existed up until like the past year or two. So it's just cool to see progression in terms of very small models, which can be run on cheaper hardware like this that actually have a decent level of intellect. So we're going to let this run for a while, and it may show that it's downloading like a few different things. So once this gets downloaded, it may download a few other things following this. But then once it is done, we will just get our first actual like interaction with it. And you can see here it's just downloading a few other pertinent files in relation to the model, and then we get a success. So we now have the tiny Gemma 3 language model downloaded on our Raspberry Pi, and we can now go ahead and actually have our first interaction with it. So this command right here will just run that model through Ollama, and we're prompting it in advance to just say hello. Now keep in mind, this is such a small model that it's not going to always accurately follow our instructions. So it will likely work here and just say hello, but it may not. So just like that, where it said more, but we can see that was actually an extremely fast result for an AI model running on a Raspberry Pi. Even if it is a tiny little model like this, this speed bodes well to actually having an offline voice-enabled chatbot, because we're not going to be waiting 10-20 seconds for each response to be spoken. So now that we have our model running and successfully downloaded, we do get to the pretty exciting part, at least in my opinion, and if you're still watching at this point, probably yours as well, where we're going to actually paste the Python script that will kind of just allow this chatbot to actually work and function. So for this, we're going to type nano and then chatbot.py. So nano is just a terminal text editor. So when we press enter right here, it will just show us like this little text editor right here. But keep in mind that it does function a little differently than like the Notes app right here. So what we're going to do, and what you will do when you're following this video, because I don't actually have that put up yet, is from wherever these instructions are listed, there will also be this long 400 something line Python script. And basically all you're going to do right here is just copy it all from start to finish, and then copy it. And then when we go into nano right here, if I just type like Control V or something like that, it's gonna, well, historically, I don't really use Windows, so I'm not 100% sure on PowerShell's behavior, but for good measure, I'm just going to type Control Shift V, and it will just give me this warning, which I've not seen anywhere. So just type paste anyway. And we now have our Python script actually pasted into this chatbot Python file. Now, because this is nano, we have not actually saved it or anything yet. So we need to type Control O, and then it will ask us here, okay, this is the file name to write. And then we press enter. And that's basically like pressing save in the Notes app or something like that. And then we're going to type Control X, which will just close nano and kind of allow us to have that now saved on our system. Our next step, very excitingly, is to actually go ahead and run this script. Now for the culmination of all of the setup steps prior to this, we can actually go ahead and get our first interaction with an AI-powered local chatbot. I do believe my speaker will have fallen asleep here, which means it turned off, so I will turn it back on and I should hear a ding. Good. So that means that our Bluetooth setup stuff did actually work, because it automatically connected once the speaker was turned back on, which is what we wanted. And the next thing here that is kind of a pain and is just something I found while troubleshooting and getting everything working, I'm running the script like this, and you will as well, where we have this mic_target here with a number next to it. This number is going to be the same number that was addressed to your USB microphone. If you do remember back when we were actually setting all of that stuff up, we had a USB mic listed in the audio sources section, and it had a number, and then we ran this command right here to actually set the default for that number. So just note the number of your USB microphone, which in my case was 66, and then run the script just like this. Now, when we run the script, it's not going to immediately start doing things. It is actually going to go ahead and download a bunch of different model files and things like that for the text-to-speech that we're going to be using and things of this sort. So basically, like these models and things right here these are actually like machine learning models that are being downloaded for both our speech-to-text and text-to-speech and probably voice activity detection dependencies. So this could take a little bit of time depending on network speed, and we're just going to let it sit. But when this is done, we'll actually be able to start speaking. Hey, how are you? So basically what we're seeing is the voice activity detection just kind of going ahead and getting a baseline for the speech. And now that it is speaking for the first time,
how about you?
The text-to-speech has actually gone ahead and downloaded these text-to-speech models so that it could speak. Now, this is obviously not perfectly synchronized. And
okay, I'm ready. Let's download the file.
What is the best kind of computer?
The best type of computer is a versatile device that can handle a wide range of tasks.
All right, so you type Control-C and that will quit out of it. Now, basically, we noticed a few things there. But first and foremost, it actually works. And while there may have been seemingly like, oh, that's a lot of latency, to actually have text-to-speech, speech-to-text, and offline AI model with Ollama, as well as voice activity detection, these are 4 kind of heavy things for a system to be running. For these to be running at a reasonable speed on a Raspberry Pi 5 8GB is actually quite good and very impressive, considering like this is something years ago I was interested in building like robots, and I still am, but I was looking for hardware that could run things locally and offline. Nothing existed, whether it be software or hardware, that would actually go ahead and run these at this speed. So having these now is really exciting, and basically it's only going to get better from here. And Raspberry Pi 5s are not necessarily known for being very performant. I mean, there are other single board computers like that have the orange Pi 5 with a Rockchip RK3588S with their neural processing unit, and those can run some of these things much faster, but the downside of that is they're a bit harder to set up and definitely not beginner friendly. So I have gone on a slight tangent, but basically what my point is here is this is a very basic, functional, relatively speedy offline local AI chatbot. I could go into this Pi right now and completely disable Wi-Fi and it would never have internet again. And this would basically work forever unless the Pi actually physically died. So that's really exciting to me. And I think a lot of folks, especially with the larger amounts of interest in AI, would be very interested in just having actually set something like this up in not really a lot of time. So this is kind of where phase 1 of this tutorial ends, where basically, congratulations, pat yourself on the back. You have set up a rather advanced offline local AI powered chatbot using a Raspberry Pi 5. It is not perfect, and partially like some of the things that may be interesting to those who want to learn more is we could take this script right here that we had just copy pasted in, paste this into an LLM. So ChatGPT, Gemini, whatever, and ask it, okay, I'd like to make some modifications to some of these parameters here, whether it be these VAD settings. So these are the settings which the voice activity detection will actually trigger. There's sensitivity there's things like that. So say it's too sensitive, we want it to not trigger as often, we can adjust that there. Beyond that, we can actually go ahead and change the model that we're going to be using from the Gemma 3270M. We can change the text-to-speech voice right here. We can change the speed that the voice is actually being spoken at. There's an auto restart delay right here, which is basically how long it will pause before it starts listening or starts the voice activity detection loop again. Basically, I guess the point I'm trying to make here is, while this may look intimidating, we essentially just set this up so that it actually works. And to go further here and tweak this to your specific needs, it is really quite possible and is the future of using these tools like AI to actually give this to an AI and say, okay, here are the changes I want to make. Here are the things I notice that I am displeased with. Please allow me or help me to implement them. And there are two types of folks out there. There are the type of person who just wants the changes made and doesn't really much care about what actually went into making those changes. So basically you paste this in, say generate the updated script with this feature, you copy paste that back in, and that's that. That's totally fine, and there are various levels of interest. There's also the person who can actually use AI to go ahead and not only help them make changes in code like this, but actually learn why and how those changes are affecting the script with the help of AI actually just implementing them for you. So like say, okay, like what is this temperature, ChatGPT? What is this num predict? And why can I change this so that it actually outputs more text and things like that? And those are all really just kind of cool areas of exploration that one could take with this if they were interested in kind of going further or learning more beyond just having a fun little AI chatbot. So that is going to wrap up the initial setup section of this script, which is probably going to end up being rather long. But the next step here, and because I do want to just put this all in one video, I'm not really big on like part 1, part 2. It's just like, don't waste my time. So the next thing to do now is, if one does want to, we are going to be able to actually now put this whole functional package into Bob the Sentient washing machine, and then basically just have this little thing on our desk with the ability to actually chat with us. Now that we have a fully functioning offline chatbot, I think it is time to go ahead and actually take the next step and build this and put it into a little device. In this case, of course, Bob the Sentient washing machine. Now, for this step, there are going to be a few kind of finicky things that we need to go ahead and get set up. And first and foremost, something here that I cannot really show on camera that will need to be done is actually connecting the screen that we're going to be using physically to the Raspberry Pi. So because I can't actually show this, I will just go over a quick reference of basically what exactly is going on here. I don't actually have one on hand because it is plugged into the Pi, and I don't want to hold that up because it could unplug it. But basically, this is a small 1.28-inch round LCD screen, which the backside of which could be seen right here. And essentially, all I have done is plugged in these connections to these specific GPIO headers on the Raspberry Pi. This is something that is really not very difficult. It's just sometimes you'll want to double check to make sure that you actually did put these in the right locations. Ask me how I know. So basically, from when we start right here, we're going to be working under the assumption that you have gone ahead and at least successfully plugged the screen into the correct GPIO pins on the Raspberry Pi. Now, with that, you can see that the coverage right here or whatever is somewhat frustrating, and there are a bit of considerations depending upon whether or not you're using a Raspberry Pi 4 or a Raspberry Pi 5, as some libraries will work with a 4 but not with a 5, or with older versions of the operating systems. So for the steps we take here that we're about to follow, I am going to be working on a Raspberry Pi 5, and I would kind of urge you to also do the same, as I can't guarantee success with these on an earlier Pi. So with all that out of the way, let's go ahead and actually begin to get this little screen working so that we can build ourselves a little Bob the Sentient washing machine. As I did turn the Pi off to actually physically connect the screen, I need to once again connect to it, which in my case I have been doing through SSH. If you are using this with a monitor or keyboard or mouse or whatever, your steps are going to be the same if you recall, but you just will be working in front of it with your keyboard instead of through SSH as I am right here. Now that we're back in the Pi, our first step is to actually enable the interface that will allow the screen to actually function. So first and foremost, we are just going to type this command or copy paste it right here, which is sudo raspi-config. Now we're going to see here that this is basically like the first time we've actually seen a graphical interface in this entire video, which is a nice thing to see. But from here, we're going to just navigate down to the third option, which says interface options, and press enter. And from here, we're going to navigate down to the fourth option, which says SPI, and press enter. Now we will see that by default this is currently disabled, and we do want to have this enabled, as this is how our little screen will actually be able to communicate and display what we want it to from the Pi. So we just hit the left arrow for yes, and then press enter. And then it will just give us a message like, okay, it has been enabled, and we can just press enter once more for okay. And the next thing to do is just basically hit finish. So you can either just hit the right arrow here, which will drop you down into these bottom two selections right here. So then one more and then press enter, and that will finish it. Or you could just kind of scroll all the way down, but the right arrow is probably the better way to go there. The next step following that is basically to add our user to the group that will allow us to actually have control over like these GPIO pins and this interface. If you recall, we also did something like this for actually getting our audio devices set up as well. So once we do that, we're just going to go ahead and reboot the device for the changes to take effect. Once we've rebooted the Pi and we're back into it, truthfully, this next bit of instruction, I don't actually know if this will be kept in the actual like GitHub repository to follow along with these instructions. So I'm just going to try it right here, but I don't actually know if this one has it installed on it. Okay, it does. Now, basically what we're doing right here is this library to actually kind of control these GPIO pins, or the little 40 pin thing on the Pi are referred to as GPIO pins. It is not working properly in the Raspberry Pi 5, so that is why we're just going ahead and removing it here. I do believe I may have mistakenly installed that when we did the first half of this tutorial, but regardless, we're all set now because we just kind of preventatively removed something that may have caused an issue. Now, in the kind of opposite scope of that, our next step is actually to install some things that will allow this display to work, which basically we can do by just copy pasting this command right here, which will install these dependencies to allow the display to properly work and also allow us to actually download the drivers for this display and things of that sort. Now, this is showing me that these have already been installed, so I do wonder, did I modify the script right here to actually include these? I don't know, but regardless, we're just going to run them anyway because it's okay to try to install things again, as if they're not there, they'll get installed, and if they are there, nothing will happen. It'll just say it's already installed, so no worries there. Next up, we're going to actually download and install the driver for this small display, which we can see the command for right here. So I am going to just run these one by one so we can kind of explain what's going on. Now here, this is preventative as we were already in that working directory, but just to make sure in case you've navigated elsewhere, because we want to just put it in the kind of home directory, which will make a little more sense when we run our final script. Next thing we're going to do is basically just download the actual driver file right here so that we can then proceed after this to go ahead and actually install it. It won't take very long as it's not really a very big file. Following that, we are just going to unzip the zip file or driver file that we have just installed, just like this. And then we will see a bunch of text kind of populate the terminal, but basically this is good because we can see somewhere in here the 1" 28, which is the tiny little round LCD that we have connected to our Pi. Now, being that you're probably used to this by now, we're not close to done yet, but we are making a bit of progress, which is always a good thing. Now, following this, we're going to want to reactivate the virtual environment that we had made for just the initial chatbot setup, as we're going to want the dependencies to allow the display to work to be installed within that virtual environment, so that when we run our full Bob chat script, everything just works from within our single virtual environment. So to do that, we're just going to change our directory into the voice chat bot folder that we had created, and once we're in there, we will just kind of, you can copy paste these things as well. It's probably easier to just do this. So we'll do this, paste it, and then if you recall, we will see that our virtual environment is activated, just kind of denoted by this right here. With our virtual environment activated, we are going to go ahead and install some of the packages that will allow everything to work nicely together. I do believe some of these may already be on the device, but as we said earlier, it doesn't actually matter. It's better to try again in most cases than to omit having installed something. And you can see that happen pretty quickly. And then we have this optional but robust. So it's probably... So basically this is just kind of like writing something on a sticky note so we don't forget it, but like in terminology that the computer would be able to understand, that I guess could be said somewhat simply. Now that we theoretically have everything installed for this display to actually work, we're going to go ahead and test one of the default sample scripts from the actual Waveshare company who we got the driver from, just to make sure that the display is actually functioning. This is just a good practice thing to do so we can see if it works or not, and then if subsequently we have problems later on with our own script, it helps us to narrow down and identify the issue. So with that, we are going to just change into the directory in which we cloned the driver and the other related folders by just pasting this in right here, and we will see that we are now in that location with this long string of path name, if you will. Now following that, the next thing we're going to do is copy this command right here, which will go ahead and run the demonstration script for the 1.28-inch little round LCD screen. Now, I do want to kind of try to show this on camera as I run it, but it's going to be perhaps difficult because this Pi is really not connected very well. The power cord is very short. So if I type this and we don't get an error, cool. So I don't know how visible this is based upon the reflection of the studio lights, but this is actually just running through its sample screen. And you can see a little round display like this, I think is pretty associated with smartwatches and stuff like that. So it's just showing us like a clock screen right now, like you would see on a round little watch. But regardless, if you do have that result, that is very good because it means that your display is not only working, but is also actually connected to the Pi and everything is set up for it to be able to communicate with the Pi. Our next step with the display tested successfully is to just go ahead and go back to our chatbot folder. Now, truthfully, I am kind of just making this instruction a little better as I go to see things that were omitted. And this is one of those things. So we are just going to type CD and then the tilde, which I did not. This keyboard's such a pain in the. Okay, there we go. Good. So we are going to just type CD and then we will type that once more and it will bring us back to our main folder right here, and then from in there we can go ahead and basically just follow this command once more to get back into our voice chatbot. Now once we're back into our voice chatbot folder, our next step is actually to just create the script that will run the full Bob the Sentient washing machine with the kind of faces and other things associated with that. So we're just going to use Nano here, and it is possible you'll just be able to clone this GitHub repository and then just run the script that way. But for this, it's just kind of a more verbose and educational method to go throughout these things. So I'm just going to call it bobchat.py, and then basically I will just paste in this entire script right here, which is actually fairly long. I think it's around 700 lines. I can see it right here. Well, not that it really matters, but yeah, so 675 lines or so, but still not super intimidating if you kind of, So we'll save it with Control-O to write out, and then we will close Nano. And our next step is not quite running it fully, but we're like very close. So the final thing we need to do before actually trying this full script is to just do what is listed right here, where essentially we're giving the system we're just telling it where the specific driver is located so that our script will actually be able to import it and use it. That's probably a non-scientific way of putting this, but that's more or less what we're doing right here. So we'll just type that, and basically once we've done that, we're able to go ahead and actually run our script, the BobChat script. But you may remember from the first portion of this tutorial where we want to kind of statically define the mic target number that we pulled when we went ahead and set up all of our audio devices prior to running the script. So I am going to make sure that I do that here right now. And beyond that, my speaker is actually turned off, so I will turn it on and then hope that it does automatically connect. Okay, that's always good. That's always like a fingers crossed moment. So now that we have everything here, I'm just going to paste this in, and you're going to notice something if I do actually manage to be able to hold the screen up while this runs. Bob has like small face images, but they're not actually currently present on this system. So this script is written to, if it doesn't find the actual face images or face sprites that it should scroll through when Bob is speaking, it will just kind of cycle through different colors just to show us like, hey, it is working. And if we put the images in the correct location, they will show up. So keep that in mind here. And I will be running this for the first time here. So I'm assuming everything will work fine, but I can't be 100% sure. All right, that's good. And now I don't know how visible it will be, but the screen is basically just going to show a variety of different colors that it will cycle through Hey, what's up? How are you?
Hanging out and ready to answer your questions. How about we chat?
Can you tell me about Bob the sentient washing machine? Also, sometimes those delays where I start talking again, that's actually just defined in the script as like the gap between when it waits for this speech to finish to allow you to start talking again. So, and then we can see the longer the outputted speech here, the longer the outputted text from the AI model, the longer it will
Bob
kind
the
of
washing
take
machine
to
is a
speak.
quirky and ingenious appliance that works in harmony with the environment. It's a marvel of engineering.
Okay, so I am just going to quit out of that, and basically there should be a way to set these text-to-speech to stream so that it kind of will just actually start speaking as it generates. I don't know how, I've not really used Kokoro before this, so I'm not very in tune with its capabilities, but regardless, we now have a fully functional Raspberry Pi chatbot setup with this display actually working properly. Now, this display can be quite an extreme pain in the butt to get working on the Pi, so if you do have it working now, pat yourself on the back, because it is something that has caused a significant amount of frustration for a lot of folks to get some of these displays working. Our next step now, which is, I suppose, quite exciting, is to actually physically assemble Bob and then place this all inside of him, and then go ahead and, I guess, just use it that way, and then, yeah. Assembling Bob is actually pretty easy, and none of the parts need to be printed with supports, as I hate support, so I never design them with it if I can avoid it. But aside from that, you can see basically all of the parts are listed, or not listed. They're all laid out on the table right here. The only thing I want to make note of is that the little washing machine door that we can see right here, I would have preferred to have printed in gray. However, I don't have any gray filament available right now. And in addition to that, the little name tag for Bob right here was also printed in gray, and that is the only piece here that is just kind of glued on. And then I printed out a little name tag and kind of just glued that on as well. So beyond that, the only tip I want to give prior to actually going ahead and getting started here is where we left off, the display was kind of attached to the Pi, just hanging like this. Now, I would highly recommend keeping these plugged into the GPIO pins on the Pi, just in case, like, you don't want to unplug one and then plug it back in the wrong spot, then have to take everything apart. So my recommendation for that is to just then go ahead and kind of unplug the actual, like, end connector from this display, because we can actually go ahead and plug that back in once Bob is assembled, and it just makes everything a lot easier to have this display separated out by itself. Beyond that, in terms of hardware, the only thing that's actually going to be required here are just some M3 nuts and screws of various lengths, which I will try to just make note of in the actual GitHub README for the assembly section. And beyond that, while this is optional, I would kind of advise having two of these little push button switches here, as the script is actually configured to have these pause and resume the script. So if you kind of just want to leave it without it constantly listening, these will be very useful. And those do actually just get slotted in the two holes right here and then plugged into two more like GPIO pins, which I will also make sure to cover. So with that, we're just going to go ahead and begin a simple installation instruction and then move on from there. So depending on how good or bad the actual video I took of building this turned out, I may just have a time lapse of simple instructions to assemble Bob. If it was a disaster, I will just probably put static photos in the actual GitHub repository for this project, which will be listed in the description. So with that, our last step here to actually get our Bob fully functional and working is once again to go to the computer or log into the Pi. At this point, you probably should just use SSH, as I don't know that I actually really thought this through in terms of how you would get it running if you were using a mouse and keyboard prior to this and a screen. But aside from that, let's just go ahead now and run the final command here, which is basically to just get the face images into the correct location on the Bob washing machine. In order to do this, it is quite simple. We're just going to clone this GitHub repository that I have put up, which just contains 4 simple and static face images, and we'll put them in the sprites subfolder within our voice chatbot directory, which will allow our final script to actually show these faces and slowly cycle through them as we actually have conversations with Bob. So once that's complete, we're basically just going to go ahead and go back into our voice chatbot repository, activate the virtual environment, and then for one final time actually run the script, which will allow this to go ahead and start conversing with us fully in the washing machine, which is a weird sentence. So once we run this, assuming everything has gone correctly, which if we're at this point, everything has gone correctly, hopefully we will just see, if I don't unplug this, the face actually go ahead and appear. Oh, thank God. And then basically we'll be able to speak to it as we have been. It will probably be a little kind of blurry here. Just, hey, what's up, Bob? How are you?
Ready to help. How about you?
Tell me your favorite joke.
Okay, here's my favorite joke. Why don't scientists trust atoms? Because they make up everything.
So basically, in the last hour and a half, we have just successfully gone ahead and not only built a completely offline local AI chatbot with a Raspberry Pi 5 with speech-to-text, text-to-speech,
Okay,
and
I'm ready to help. Let's get this sorted out.
voice activity detection, but we also went ahead and went a step further and actually put it in a little fun Bob the Sentient washing machine case that we can freely make and print and things like that for personal use only. If you try to sell these, there's going to be some legal issues. But beyond that, basically the only other thing I neglected to show is just the pause and resume button. So that button right there will just pause the script, and then the other one, if you do opt to actually put these set up, will resume it. Just like that. So basically, that is the, I guess, the end of this video, which is weird. I haven't really planned for this, but basically, I wanted to do something. I know a lot of folks were very interested in not only Bob, but kind of just being able to do something like this with a Raspberry Pi. So I wanted to do a really intricate, in-depth tutorial on actually setting up a local offline AI chatbot with a Raspberry Pi in a way that pretty much anyone can go ahead and actually do themselves. So with that, that is going to wrap up today's very long video. If you have any questions, please feel free to subscribe. And following that, I will probably put some of I have like 5 or 10 of those little screens. So maybe I'll put like a BYOP, like a bring your own Pi kit on my website. If anyone really feels like they want to spend like money for something they could just print themselves just to get it shipped all in one kind package, maybe I'll do that. If I do, I'll put it in a pinned comment. All right, that is going to conclude this. The GitHub repository link will be in the description so you can follow along just kind of by copy pasting into the terminal. And thanks for watching.